Okay, so till last class we studied about, right? We studied about the basics of ionic equilibrium, right? The types of electrolytes, weak electrolyte, strong electrolyte. Okay, then we talked about pH of weak acid, weak base, mixture of weak acid, weak base, strong acid, strong base, and all those things. Right, everyone? So in this class, we will study about solvents. Okay, so first we'll study about solvents, then we'll study about what are the effects of solvent in equilibrium, right? And then there's a property called as common ion effect, which is almost same as Le-Chatelet principle. Okay, then we will discuss what is common ion effect, right? Then again we will discuss the pH of remaining electrolytes, which is salt, right? Salt of strong acid, salt of weak acid, soluble salts, non-soluble salts. Okay, right, everyone? Okay, now first, when we talk about solvents, right? When we talk about solvents, we know that what is solvent, what is solute. I hope everyone know what is solvent, what is solute. Just raise your hand. Tell me, everyone know what is solvent, what is solute, right? Very good. Okay, so when we talk about solvent, there are two types of solvents. Okay, there are two types of solvents. First is polar solvent, second is non-polar solvent. Okay, polar and non-polar. So think about it, right? When we talk about solvent, we have polar and non-polar. Now, when we talk about polar or non-polar, I hope everyone know what is the meaning of polar and what is the meaning of non-polar. Okay, so polar solvent are the solvent which have polarity, and non-polar solvent are the solvent which is, tell me, non-polar, right? For example, when we talk about organic solvents, okay, most of the organic solvents are which kind of solvent? Tell me, which kind of solvent? Yes, very good. So most of the organic solvents, I'm not saying every organic solvent, but most of the organic solvents are your non-polar solvents. Yes, very good. Right, everyone? Very good. Okay, now, since we're talking about ionic equilibrium, we talk about ions. Okay, we talk about ions. So obviously, we will basically talk about polar solvents. Okay, so these are the top type of solvents when we talk about. It is polar solvent. Now, polar solvent, okay, right? Polar solvents are of two types, protic solvent and aprotic solvent, right? So polar solvents are of two types, polar solvent and, sorry, protic solvent and aprotic solvent. Now, what's the meaning of protic? Just think about this. The word protic comes from proton, right? Which basically means H plus, okay, H plus. So basically, protic solvent and aprotic solvent means solvent which have exchangeable H plus, exchangeable H plus, right? Okay, and aprotic solvent is that solvent which do not have exchangeable H plus. Got it, everyone? So I hope everyone remember what is the meaning of exchangeable H plus, right? So exchangeable H plus is that hydrogen which is attached with higher electronegative atom, right? Remember, everyone? Tell me. Remember? Yes? Okay. Now let's see. Protic, right? Protonic or protic solvent. So if we have presence of transferable hydrogen or exchangeable hydrogen, right? Then the solvent is called as protic solvent. Got it? Tell me. Protic, right? Or it is written as polar protic solvent. Okay, anyone have any issues, right? For example, H2O, NH3, H2SO4, HX, right? All of them are polar protic solvent, polar protic solvent. Got it? Anyone have any issues? Tell me. Anyone have any issues? Right? Easy to understand? Okay. Protic, which contains proton, which contains exchangeable hydrogen, as simple as that, right? Now, aprotic solvent, as the name suggests, aprotic, which means which do not have replaceable hydrogen or do not have exchangeable hydrogen. For example, see, if you see the example, most of the solvents are your organic solvents, right? Most of the solvents are organic solvents, right everyone? Okay, got it? Tell me. Now, see, as I said, there's a difference between polar and non-polar, right? Even though aprotic solvent, right, is just mean that do not have replaceable hydrogen. Okay, so even non-polar solvents can have aprotic solvent. Got it, everyone? Yes, because what is the meaning of aprotic solvent? It is just the solvent which do not have exchangeable hydrogen, right? So both polar solvent may not have hydrogen, or non-polar solvent may not have exchangeable hydrogens. Okay, so when we talk about polar solvents, it consists of both polar and non-polar, right? But if I'm saying polar aprotic solvent, right? So it means only polar solvents which do not have exchangeable hydrogen. For example, when you talk about DMS, so dimethyl sulfoxide, right, or CH3CN, okay, THF, right? They are usually polar solvents. They are polar aprotic, right? But when we talk about C6H6, C6H12, they are just non-polar aprotic, non-polar aprotic. Got it, everyone? Tell me, got it? Tell me, yes or no? Yes or no? Anyone have any issues, right? I hope everyone is clear about that. Okay, right? Now the second question would be, okay, so what is the effect of these solvents in equilibrium, right? Right? What is the effect of these solvents? What does this solvent do, right, in any chemical reaction, right? So we know that most of the reactions take place in the presence of solvent, right? So there are some solvents, right? Just see this, right? We have leveling solvent, right? What is the meaning of leveling solvent? Okay, now think about this. Think about this. When we talk about 10 to the power minus 8 molar HCl, okay, how many of you remember this question? Right? Everyone remember this? So most of you say that pH would be 8, right? pH would be 8, but obviously it is wrong. Obviously it is wrong, right? Yes or no? Yes? Now let's see, right? First of all, we will see this example, right? We will see this example, right? How come it's not 8, right? How come it's not 8? Let's see this example. Now let's see, right, everyone? We have 10 to the power minus 8 molar HCl solution, right, everyone? HCl solution, yes. Now what is the meaning of HCl solution? It means, right, we have 10 to the power minus 8 molar HCl in presence of acid, sorry, in presence of H2, yes or no? In presence of H2O, right? Tell me, yes. So we have HCl, right, HCl, which will give H plus plus Cl minus, right? Now the concentration of this H plus is 10 to the power minus 8. Okay, no issues as such. But we have H2O also, which will also dissociate into H plus plus OH minus. Right? Now I'm using some approximation over here, right? I'm using some approximation, right? Because after studying common line effect, okay, we will see the exact equation, right? But I'm using just approximation. So I'm assuming that it will be, right, mostly it will be neutral because this concentration is very less, right? It will change. The thing is, it will change to a very small extent, right? But we can take approximation because this value is very small. Okay, this value is very small, right? Now tell me, what is the total concentration of H plus. Tell me, what is the total concentration of H plus? Tell me everyone. Because volume would be same, right? Because obviously it is mixed in H2O. So total concentration would be 10 to the minus 8 plus 10 to the minus 7. Agree everyone? Agree? Yes or no? Right? Now what's the meaning of 10 to the minus 8 plus 10 to the minus 7? We can take, what we can take common? We can take 10 to the minus 8 common or 10 to the minus 7 common. Which is bigger? 10 to the minus 8 is bigger or 10 to the minus 7 is bigger? Think about it. 10 to the minus 7 is bigger, right? Right, very good. So we will take smaller one common. So 10 to the power minus 8 we will take common. So we will get 1 plus. Now, this is nothing but 10, yes or no? Right? If you take 10 to the minus 8 common, it will be 10, right? Anyone have any issues? No? So see, if you remember this, it will become 11 into 10 to the power minus 8. Okay, right? So this is concentration of H plus. Now think about this. What is pH? pH is equal to minus log concentration of H plus. Right, everyone? Now it is minus log, right? Now it is 11 to the minus 8, so it will be minus log 11, right? Minus log 10 to the power minus 8. Okay? Okay, everyone? Right? So if you see this, we will have 8 minus log 11. Right? Now tell me, what is the value of log 10 base 10? Obviously it is base 10, right? What is the value of log 10 base 10? Tell me, it is equal to 1. So obviously if it is log 11, it should be something more than 1. Yes or no? Something more than 1, right? So it is 8 minus, it is approximately, I can take 1.0234 whatever, right? So I'm just taking 1.04. So it will become 6.96. If you take 1.02, it will be 6.98, right? So obviously it will be slightly less than 7. Got the concept? Tell me, got the concept? Anyone have any issues? Think about it. Yes. Okay? Okay? Right? So I hope all of you understood this. Okay. Now we will discuss what we were discussing about the solvents, right? So next is what we were discussing was leveling solvent or leveling effect, right? Leveling effect. Now it is leveling effect. So this is very important, right? Just think about this. Now, this is just a theory, right? This is just a theory. So what is the meaning of leveling effect, right? Or it is also called as solvent leveling, right? Now, when we think about some solvents, just think about some solvent, right? Okay, when we talk about some solvents, solvents can also behave as acid base or salts. Okay, solvents, right, can also behave or can also have a property of acid and base. Tell me yes or no, right? Right? Now think about it. Now think about it. Suppose I'm having a solvent A. Suppose I'm having a solvent A which is acidic in nature. Just think about it, right? I'm having a solvent A which is acidic in nature. Okay. Now, when we talk about the solvent, right? Now, if in this solvent, we dissolve strong base, B, right? Strong base or base. We dissolve strong base B. Now tell me what will happen. Tell me. Tell me what will happen. Basic common sense, right? Just think intuitionally. What will happen? What should happen here? Okay. Yes. So you can say that some of the base, right? Some of the base will be neutralized by acid, right? Okay. Or you can say that the strength of this base can be leveled by this acid. Yes or no? Right? Yes or no? Right? Because this base will react with H plus of this acidic solvent. Okay, and result in the formation of a strong acid which is HA. Yes or no? Tell me. Yes or no? Right? Now this is your leveling effect, as simple as that. Right? This is your leveling effect. Okay, because it just complex the term, right? This is your normal leveling effect. Okay, everyone? Right? Tell me. Yes? Okay, now just think about this. Think about this. Suppose we have an acid. We have an acid which is, this is a solvent H2O and an acid which is stronger than H2O, right? Suppose we have an acid which is stronger than H2O. Suppose we have HF. Okay, right? Now what do you think? What will happen here? Tell me, what will happen here? Tell me. I can say that this acid is stronger than H2O because H2O is amphoteric. It can behave as acid or base, right? So this is your strong acid. Strong acid. So in this case, H2O, right? H2O will behave as a base. Okay, right? And HF will take out this H of H2O and form H3O plus F minus. Agree? Yes or no? Just think about it. Agree? So can I say that? Can I say that HF cannot exist in water or cannot exist in H2O in HF form? It will dissociate. Tell me, right? So I can say that any acid which is stronger than this H3O plus, right, will react with H2O to form H3O plus. Okay, right? Hence, it will not exist. Okay, it will not exist in H2O. Yes or no? Tell me yes or no. Are you getting the concept? I'm just giving you the idea from the concepts, right? From the examples. Not just think about this. Just think about NH3. Now think about NH3. Okay? Okay? Right? Now in case of NH3 also the same thing will happen. Right? NH3 plus HCl. What will happen? Tell me. NH3 plus HCl. What will happen? Right? Will form NH4 plus Cl minus. Right, everyone? Okay, now I hope all of you understood the example. I hope all of you understood the example, right? So let's see. So this is what I was saying, right? Now, when we talk about according to Bronsted-Lowry theory, right, it can be extended to non-aqueous solvents also, the acid-base reaction in non-aqueous solvent, right? Okay. Now think about this example: HCl plus CH3COOH. Now, since it is your strong acid, this acid, even though it is an acid, it will act as a base. Yes or no? It will act as a base, right? Okay, right, everyone? Okay, so just focus on the second concept. As I said, in water solvent, mineral acids, right? Mineral acids, right, are equally strong because of their complete ionization. Okay, right? Water is here as a leveling solvent because it levels all the acid of the same strength. Got it? That's what I said. Tell me yes or no. Okay, I hope all of you understood the basic concept. It's just a theory. That's it. It is just a theory. Okay, right, everyone? Tell me, you understood this or no? Tell me. Okay, see, try to remember from example. Okay, try to remember from example, right? As simple as that. Okay, now next concept is common ion effect, right? Next concept is common ion effect. Now think about this, right? Before understanding common ion effect, right? Think about Leach-Astley principle, right? Now let's think about this Leach-Astley principle. Okay, what is Leach-Astley principle? Tell me. I hope everyone remember Leach-Astley principle, right? I hope everyone remember Leach-Astley principle. Suppose I'm having CH3COOH, okay, right? Plus H2O, obviously plus H2O, then it will just CH into what? CH3COO minus plus H plus H3O plus. Agree everyone? Tell me, agree everyone? Anyone have any issue in this? Anyone have any issue in this? Okay, now if we talk about equilibrium, right, it would be, suppose it is C 0 0, right? Then our at equilibrium it would be C minus C alpha, C alpha, C alpha. Okay, okay, everyone, right? No issues as such. So this is case A. Case A. Now suppose I'm having case B. Case B, right? Apart from CH3COH, now I'm having CH3COO minus Na plus. I'm having this also. Okay, I'm having this also, right? And suppose this is C mole and this is B mole. Then tell me what will happen. This is your salt, so obviously this will ionize completely, right? Okay, right? Now what will happen? What do you think? What will happen? Now in this case we have CH3COOH plus, or just remember it like this, gives CH3COO minus plus H plus. Now initially it is C, initially it is B now, and it is 0, right? So at equilibrium it will be C minus C alpha dash, it is B plus C alpha dash, and this is C alpha dash. Got it everyone? Tell me, got it? Anyone have any issue till this point? Tell me, anyone have any issues till this point? No? Okay. Now tell me this. Among alpha and alpha dash, what do you think? Which is greater? Alpha is greater or alpha dash is greater? Alpha is greater, alpha dash is greater. Yes, Riya, very good. Yes, very good. Yes, very good, everyone. It is alpha. So if you remember, we are increasing the concentration of reactant now, right? Sorry, product now, because CH3COO minus is a product, right? By using CH3COO minus Na plus, right, or by having CH3COO minus Na plus, the concentration of product is increasing, right? So obviously the direction of, it is a reversible reaction, my bad. So the direction of reaction will shift in backward direction, right? So according to Lee-Chatelet principle, right, if it is shift in backward direction, the degree of dissociation should decrease. Yes or no? Degree of dissociation should decrease. So alpha should be greater than alpha dash. This is your common ion effect. Okay, everyone? This is a common ion effect because this common ion, right, will leads to less dissociation of your acid or base or whatever you have reactant. Okay, right? Now if B is very like larger than C alpha dash, then it can also be ignored. Okay, right, everyone? Tell me, understood this concept? Okay, okay, everyone? Yes, very good. So I hope all of you understood common ion effect. So common ion effect is Lee-Chatelet principle in ionic equilibrium. Okay, right? And Lee-Chatelet principle due to concentration or pressure, as simple as that. So mainly due to concentration. Okay, okay, everyone. Okay, now let's see. Let's solve one simple problem. Okay, let's solve one simple problem. Okay, so I hope all of you can see the problem now. Tell me, all of you can see the problem. Think about it, right? First question that you should ask, right? First question you should ask is, what is this? Strong acid, weak acid, strong base, weak base, right? Okay, then what is given? We have solved problem like this. Everyone, if you remember, we have solved problem like this, right? Okay, let's see. So first of all, it is your determine the degree of dissociation of 0.05 molar NH3, right, at 25 degrees centigrade in a solution of pH 11. Okay, now you might be confused by this reaction. Okay, now what is this reaction? Actually, this reaction is nothing, it is just NH3 plus H2O. Okay, right? gives NH4 plus OH minus. Okay, got it? Tell me, yes or no? Because NH3 plus H2 will react to form H4OH, which will distillate to give NH4 plus OH minus. So this is your reaction. Even if you don't think about this reaction, it is a reaction. Okay, right? This should be clear with your normal concept. Now we know that. Okay, what we know already, we know that the pH is 11, which means concentration of H plus is 10 to minus 11. But here we are getting concentration of OH minus. So if concentration of H plus is given, we can calculate concentration of OH minus. How? We have ionic product of water, right? We have ionic product of water. Agree? Right? So this is concentration of OH minus, right? Which is 10 to minus 3. Now this should be equal to C alpha. Okay. I hope all of you remember we have done a similar problem like this. Yes or no? Right? We have done a similar problem like this. Yes, very good. 0.2%. Okay, it's 0.2%. Sorry, it is 2%. Sorry. Okay. Yes, module. Now let's see question number. Next question, everyone. Next question. Can you see next question? Try solving next question, everyone. Try everyone. Question number 6. Try everyone. See the components, right? Components are weak or strong electrolytes. Tell me, components are strong electrolyte or weak electrolyte? Tell me. Strong, very good, right? So if they are strong, right? So you just have to dissociate it completely, right? Calculate H plus, OH minus, neutralize, and see what is remaining. Okay, right? Try it, everyone. Step by step, right? Try to remember all the concepts step by step, right? It should not be haphazard. Okay, make a mind map. So first, what is given? pH. You have to find pH, right? But pH of HCl is given. So if pH of HCl is given, you can find the concentration of HCl, yes or no? Tell me. Yes or no? Yes, you can find the concentration of HCl, which is 10 to minus 2. Okay. Now concentration of HCl will be same as concentration of H plus. Yes, right? And volume of HCl is given. So I can say that number of moles of H plus is equal to M1 into V1. Right, everyone? Tell me. Right? And same goes with NaOH. Okay? Okay, Anamika, very good. Let's see. Okay, let's see. Same goes with NaOH. Now, if you see this, if you see the reaction, right? If you see the reaction, okay, you will get to know that H plus is used, H plus is consumed. Okay, yes, pH is approximately 11. Yes, everyone, very good. So pH is approximately 11 because you can see that, right? pOH is 2, so concentration of NaOH is minus 2, right? So multiplying by volume, you will get number of moles. Okay, so right, this is 2 and this is 3, right? So you will know that limiting reagent is HCl, right? So 1 mole of NaOH will be left, okay, which means 10 to the power minus 1, 10 to the power minus 1, right? Mole of NaOH minus, and total volume is 500, so it is 1 by 500, which is this is your concentration of OH minus. Right? I hope all of you remember we have solved problem like this also. Yes? Now try to solve this one. Try to solve this one. Everyone try to solve this one. 7th one. Okay, everyone try to solve 7th one step by step. Think everyone. So calculate for its decimolar solution. So concentration is already given. It is decimolar. So concentration is already given. Okay. Right. So I guess, yes, very good everyone. So first one is easy, right? Very good. So you know that K is very small. If K is very small,
now connected to desktop KCGQ79U.
Sorry, my bad. If Kc is very small, right, you just have to use the formula, right, everyone? You just have to use the formula, and we know that alpha is equal to K by C. We have already derived it, and decimolar means 1 by 10 molar, right? Deci means 1 by 10. Deca means 10, right? So this is just formula putting getting. Yes or no? Just formula putting getting. Agree, everyone? Tell me, agree? It was formula putting getting. We have solved this kind of problems. Okay, very good, everyone. Now try this problem. Everyone, try this problem. Try this problem, everyone. See, because when we talk about concepts, right, if you think about it, the concepts does not include, right, anything extra that what we have studied in chemical equilibrium. Yes or no? Right? Most of the concepts that we have studied in chemical equilibrium are used here, right? Only the type of reaction is changed. Okay. Yes. So numerical wise, you have to do the same thing that we have done in chemical equilibrium. So it will be more of practice of chemical equilibrium. I hope all of you remember this question. Tell me, I hope all of you remember this question. Now, all of you have already solved this question. Okay, all of you have already solved this question, right? How come? See, right? If you remember this, it is actually 10 to the power minus 8 molar. Concentration is actually 10 to the power minus 8 molar because you are mixing this with 1 liter, which is 10 to the power minus 5. 10 to the power minus 5, whereby 10 to the power 10 power 3. Okay, which is 10 to the power minus 8. Okay, millimoles. Right? Got it? I hope all of you remember this. I hope all of you remember this. Right? Yes, so common line effect due to H2O. Agree? Agree, everyone? Very good, everyone. Okay, right? So next is properties of water. We have already discussed the properties of water. First, it is your amphoteric in nature. What is the meaning of amphoteric? It can behave as both Bronsted acid as well as base, right? Molar concentration or molarity is 55.55. We have already studied that. How, right? Then antiproductive water we have studied. Antiproductive water is Kw, which is concentration of H plus into concentration of OH minus, right? This is equal to 10 to the minus 14 at 25 degrees centigrade, and this increases with increasing temperature, which suggests that it is your endothermic reaction. Okay, now we know that if the pH of water is greater than 7, it is your, tell me, basic solution, right? If it is less than 7, acidic. If it is equal to 7, neutral. Okay, then degree of dissolution of water we have studied, right? Okay, tell me. Yes, you can find it easily because you know what is the number of moles of H plus by molar concentration of H2O, right? So you will get 1.8 10 power minus 7, right? 1.8 10 power minus 7. If you see this, right, this is very, very small as compared to 1. Yes or no? Very, very small as compared to 1. That's why whenever we take any acid or base, we neglect this, right? We neglect the concentration of H plus, right? Got it? But when we can't neglect, when the concentration is all most of this range, means when the concentration is around 10 to the power minus 6, right, or greater than 10, sorry, less than 10 to the power minus 6, then we cannot neglect the concentration of H plus in the solvent. Yes or no? Tell me, yes or no? Agree, everyone? Agree? Okay? Okay, everyone. Very good. Now, pH scale, we have already studied what is pH scale. Okay. The next topic, right, or which is basically your one of the most important topics, which consists of almost all the numericals, is find the pH, right? So now you can give your heading, find the pH of all the types of electrolytes. Okay, we'll study it one by one once again, right? Now the first is pH of strong acid solution. I hope everyone remember strong acid solution. Tell me yes or no, right? It will just dissociates completely. So that's the thing that I was saying to you. If it is greater than 10 to the minus 6, if it is greater than 10 to the minus 6, then H plus from water can be neglected. Right, everyone? I just said that, right? Got it? Now, if it is less than 10 to the minus 6, but greater than 10 to the minus 8, right? Okay, then H plus cannot be neglected. Okay, then H plus cannot be neglected. Okay, you have to add H plus of water, right? We have already solved the problems, okay, right? In case of this, when we have 10 minus 8 molar of HCl, okay, now see, this is the exact method, right, that I was talking about. This is the exact method. I hope all of you remember using common ion effect, right? Okay, so it is something, it is 1, suppose, so it is initially tested on minus 8, H plus because of acid. So when H2 will dissociate, it produces X amount of H plus and X amount of OH minus. Okay, now this is your complex calculation, right? But if you solve this, you will get, see what you will get, right? I hope all of you remember this. Tell me, right? You're getting pH almost equal to 7, which is 6.98 only, right? Okay, so you can take this approximation that I have taken. Okay, without any issues, you can take the approximation that I have taken without taking this X and getting this quadratic equation. But this is the method. Okay, right? I hope all of you remember this concept of common ion effect. See, here also I've taken B plus C alpha and C alpha dash, right? Yes or no? So the same thing will happen with H2O also. But as I said, if this C alpha dash is very, very less than B, I can neglect this. Yes or no? Tell me. Right? Okay? Right, everyone? So that's what I did in last class. Sorry, last question. Now, strong base, same as that, right? Strong base, same as that. I hope anyone have, tell me, I hope anyone won't be having any issue with this. Tell me, yes or no? Yes or no? Strong acid, strong base, mixture, strong acid, mixture, strong base. All if you can calculate, right? When concentration is greater than 10 to the minus 6, no issues. When concentration is less than 10 to the minus 6, take the concentration of H plus also. Just take it as 10 to the minus 7, no issues. You don't have to take XX, okay? Because obviously you will be writing your competitive examinations where you will have options, okay? Right? Just take example of 10 to the minus. Now let's see this one. If I take 10 to the minus 7 as it is, right? Instead of taking this, I'll take 10 to the power minus 7 only. Then what would be the answer? Then total concentration of H plus would be what? 10 to the minus 7 because of water plus 10 to the minus 7 because of this NaOH. So total it will be 2 into 10 to the minus 7, right? Right? So pH would be what? pH would be 7 minus log 2. Right, everyone? Tell me, right? Okay, sorry. This is concentration of OH minus. Sorry, concentration of OH minus. Okay, concentration of OH minus. So POH will be what? 7 minus log 2, which is equal to 6.7. Yes, because log 2 is 0.3. Okay, so if you calculate pH, you will get what? You will get 7.3. This is an approximate answer. Right? That we took just by taking 10 to the minus 7. See the exact answer. The exact answer is this: 6.79 and 7.21. Tell me, is it close? Yes or no? Is it close, right? Tell me, it's close? Agree? So when you talk about your objective questions, you can just take this. You don't have to solve this lengthy quadratic equation, but you should know the method. Okay? Okay, everyone? Okay. Next, pH of mixture of two acid, right? So see, here it is taking NN because they're using equivalent concept, right? Using normality that we will study in redox reaction. But what I'm suggesting is use mole concept, take molarity. So it will be M1V1 plus M2V2 by V1 plus V2, right? After redox, you will understand what is the difference between molarity and normality, but you can just take this, okay? Right, everyone? Right? We have already solved problem based on this. I hope all of you remember this problem. Tell me, how many of you remember this problem? Right? A problem like this, not exactly this, a problem like this we have solved in module. Yes, can you try it once? Everyone please try. Everyone please try. They have two base, right? Two strong base. Okay, two strong base. Now think about this, right? Again, sorry. So either you can calculate OH minus individually, right? Which is OH minus because of NaOH. Okay, number of mole of OH minus from NaOH. NaOH is equal to what? M1V1, which is 500 into 10 to the power minus 5 millimoles. Then moles of OH minus from BaOH का whole twice. Now we know that 1 mole of BaOH co gives 2 mole of OH minus. So we will get 2 into 500 into 2.5 into 10 to the power minus 5. Right, everyone? Now we have concentration of OH minus is equal to N total by V total. What is N total? Add them, right? If you add them, you will get what? Tell me. You'll get what? It is 5 plus 1 into 500 into 10 to the power minus 5 divided by 500 plus 500, 1000. Okay, 2 times, 3 times, so it will be 3 into 10 power minus 5. Yes or no? Tell me. Yes or no? Right? Okay. I have taken this approximation. Right? I've just taken this approximation without using the values. Okay. Okay, everyone. Right? But you can take exact value also because it is almost 10 power minus 5. Okay. So without taking without considering H plus of water, right? You will get this as answer. Okay, everyone, tell me. Okay, right? Understood? Okay. Don't worry, you won't be getting many of these kind of questions. Okay, so most of the question would be like this. Okay, most of the question would be like this, where the concentration, right, will not be very less, where you don't have to use common ion effect. Okay, right, everyone? Now see this, in this question number 13 and 14, we have solved question number 13 and 14 or questions like 13 and 14, where we have to calculate the concentration of H plus and concentration of OH minus, neutralize them, see which is remaining, either H plus or OH minus, right? And then find the pH or pOH respectively. Got it, everyone? Tell me. We have already completed this in last class. That's why I'm just asking you if you actually understood the concept or not of strong acid, strong base only. Okay. Just raise your hand. How many of you understood this concept in last class? Tell me, raise your hand. If there's anyone who didn't understand this concept, please let me know. See, you have to calculate H plus from acid, OH minus from base. Okay, neutralize them, right? If you have suppose 10 mole of H plus and 15 mole of OH minus, so obviously 5 mole of OH minus will be left. Calculate POH by N total by V total, right? And then subtract from 14, you get pH. Okay, so this is what it has been done here, concentration of H plus. So we have M1 into V1, which is concentration of H plus of this acid, minus, right, M2 into V2 into 2, because which is concentration of OH minus, because it will neutralize by 100. Okay, as simple as that. Okay then, right? So I hope all of you are clear with this. Strong electrolyte, all of you are clear. Then we have for weak monoprotic solutions. So I hope everyone remember this. Everyone remember this. Tell me, yes or no? Everyone remember this? Yes or no? Right? We have derived this in last class. Okay, that if we have a weak monoprotic acid, then we can use Osmo dilution law, right? By ignoring alpha, we can say that Ka is equal to C alpha square, right? K is equal to C alpha square. Then alpha is equal to root K by C. Okay, and concentration of H plus is C alpha. So it will be root K into C. Then take log, you get pH. Okay, right, everyone? Step by step. I'm just revising all the concepts step by step. For those who have missed it or couldn't get, okay. Now, what are the type of questions, right? Because in that case, right, when we have weak monobasic acid, so first of all, you have to identify what is weak monobasic acid. So these are weak monobasic acid, right? Now, first, what you have to do? Calculate alpha. That's the first thing you have to do, right? So try to calculate alpha for A and B, both. Everyone, calculate alpha for both A and B. Tell me. Guys, please try everyone. Everyone should try. Right, everyone, right? I hope all of you have tried. So first step that you should do, directly calculate alpha, right? Use formula and calculate alpha. Okay. Now, if you calculate alpha for first case, right? If you calculate alpha for first case, you would get this. Alpha is almost less than 0.1. Yes or no? Okay, very good, everyone. Very good, everyone. So first case, right? If you see the first case, right? Alpha is almost right less than 0.1. So obviously we can use the formula. Then we can just calculate using formula, which is 2.85. Very good. Second one, if you check the second one, in second case, alpha is not very less. Alpha is greater than 0.1. Right, everyone? So in this case, you can calculate, but answer would vary. Okay, right? Answer would vary. So if alpha is greater than 0.1, okay, you cannot ignore this. You cannot ignore this. So you will get a quadratic equation, right, everyone? But let's see what would be the difference if we calculate using this formula and without this formula. Okay, everyone, right? Now let's see. See, now if you see this, right, if you calculate using this formula, right, without ignoring, we will get alpha is equal to 13%, which is not less, right, everyone, which is not less. But if you would have calculated using this formula, right, tell me what would have been the answer. Tell me. Root 2 is equal to 1.414, so 1.4 into 10 to the minus 1, so it is almost 14%. Tell me yes or no, right? Yes. So if you have less time, if in an exam you have less time, right, you can actually eliminate your answers by approximating. Okay, I'm not saying you should do this, right? I'm just saying if you don't have time for solving, right, if you find it hard, instead of leaving, just use this unless and until alpha is very large. Suppose alpha is 0.4 or 0.5, then you should not do this. But alpha is close to 0.1, then you can do this, because if you see the difference, it is less than 1%. Yes or no? Tell me. Yes or no? The difference is less than 1%, right? So the difference in pH will also be not very much. Okay, right, everyone? Okay. Now next is pH of mixture of weak acid and a strong acid solution. Now in this case, what will happen? Tell me. In this case, we will have a common ion effect, yes or no? Tell me, yes or no? Yes or no? Tell me, everyone. Yes, we will have a common ion effect, right? So see, initially it will be C2 from this acid, right? H plus A minus. Okay, now we will have strong acid, which is C1. weak acid, which is C2. So C2 will dissociate, right? It will be C2 1 mass alpha, C2 alpha, C2 alpha, but this H plus will also be there because of strong acid. So C1. Got it? Tell me. So this is your equilibrium concentration. Okay, everyone? Tell me yes or no? Yes or no? Right? Now this is what I said. Now this is what I said. Calculate the concentration of H plus from strong acid plus H plus from weak acid. That's what I said. Yes or no? If you remember, this is what I said in last class also. Right? Tell me. Total H plus is concentration of H plus from weak acid plus. Okay. Right, everyone? Now, if this is very small, if this is negligible, you can just neglect it, you will get this as answer. Okay, right, everyone? This is what it is written. Okay, okay. Now, this is the thing that I have told you, the pH of mixture of two weak monoprotic acid. I hope all of you remember the formula. Tell me, what is the formula, everyone? Tell me, at least you should remember the formula. What is the formula? Ka1C1 plus Ka2C2 whole under root, right? Concentration of H plus. Yes or no? How many of you remember this formula? Tell me, how many of you remember this formula? Raise your hand. How many of you remember this formula? Right? Yes, very good. Now let's see. Let's see. Now in this case also, I told you the concentration of H plus will be the concentration of H plus from first acid plus concentration of H plus from second acid, right? So I hope all of you remember the simultaneous equation. Tell me, simultaneous equation from chemical equilibrium. So it will be something like this. Just use normally using simultaneous equations, right? So this is a first acid, which is HA1. Okay, so it will dissociate into H plus plus A1. Okay, now for this it will be C1 1 mass alpha 1 and it will be C1 alpha 1 C1 alpha 1. But since again both of them are mixture, right, we will have the concept of simultaneous equilibrium. I hope all of you remember X Y, then it should be X plus Y in both. Right, everyone? Tell me. Right? Anyone have any issue until this point? This I've told you how to derive. Okay, I've gave you a hint and I've asked you to derive at your home. Now, if you see this, just think about this. If you see these two, if you remember the concept of chemical equilibrium, and whenever we had this type of problem, what we used to do, so obviously this is very small, so ignored. We used to take the ratio, yes or no, Ka1 by Ka2 is equal to C1 alpha 1 by C2 alpha 2. Agree, everyone? Agree, everyone? We used to take ratios. I'm just using the concept of chemical equilibrium, nothing else. Okay. Sorry, CC will get cancelled. My bad, right? Here C1 will get cancelled, right? C2 will get cancelled. So I will be just getting this alpha 1 by alpha 2. Alpha 1 by alpha 2. Okay, right, everyone? Right? So see this. You will be getting just this one, just this one. Now we know that concentration of H plus. Just think about this. Concentration of H plus is C1 alpha 1 plus C2 alpha 2. Yes or no? Tell me. See this. This is what I have been telling you every time. Concentration of any mixture is nothing but sum of concentration of H plus or H plus OH minus, right? Now, I can replace alpha 1, I can replace alpha 1 with alpha 2, right? Or I can use this equation, okay, right? And this equation to get alpha 1 because I'm having equations, right? So alpha 1, if you think about alpha 1, alpha will be this. Alpha 1 will be this, alpha 2 will be this, right? Using this equation, okay, right? And if you add them, you will get C1 Ka1 plus C2 Ka2 divided by root of same thing, Ka1 C1 plus Ka2 C2, right? So obviously you will get root K1 C1 plus K2 C2. Now tell me, isn't it the same concept that we have used in chemical equilibrium? Think about it, think about it. So ultimately you just have to remember this, okay? Ultimately you just have to remember this. Okay everyone, in your short notes you should write this. Okay everyone, now for same thing can be done for base, same thing can be done for the base, right? Okay, now before solving, try to solve this problem. Tell me, try to solve this problem. Everyone, try to solve question number 16. Please try to solve question number 16. Sorry everyone, I forgot to record the last 10 minutes of the class. Okay, so I hope all of you understood these type of problems. Yes or no? Tell me. Tell me everyone, I hope all of you understood these type of problems. So we are done with acid and base. Yes or no? We are done with acid and base. Anyone have any issues? Be it strong acid, strong base, mixture of acid base, weak acid, weak base, mixture of weak acid, mixture of weak base. I hope everything is clear, right? I did not want to confuse you. That's why I spent one more class on same acid base concepts, right? Everyone is clear about acid and base. Salts we will discuss from next class, next week. Okay? Okay, everyone? Okay. Okay, everyone. Thank you, everyone. Now you can solve 8.2. Okay. So homework would be 8.2 till Monday's class. Okay. You can solve 8.2 completely now. Okay. Right. Please watch the videos. If you have any doubts, please message in the group. Right. This chemistry doubt solving group. Okay. Even if you have small doubts, message in the group. Okay. Okay, everyone. Bye, everyone. Thank you. Thank you, everyone.